Jenny. Welcome
Hello.
to our GitHub podcast for this month. It's so nice having you here. My name is
Thank you.
Odola and I'm from Stellenbosch University. I work with Tobiola Nikbekun on Bioinforma, and what we do on this platform is that we try to empower young female from underdeveloped country on bioinformatics. We believe that we should have more of women in that field. It shouldn't be
Mhm.
male dominated field. So thank you for honoring our call to be with us on this podcast. I know that you are a bioinformatician yourself,
Mhm.
and if you don't mind, will you tell us how you started your journey? Did you study bioinformatics at undergrad level?
No, yeah, so thanks again for having me here. My background is biology and computer science. So as an undergrad, I just had a biology major and I was studying on that going well, but I felt that a lot of people around me were pre-med, so they wanted to go be a doctor. And or like the other emphasis was like environmental studies, like ecology. And so I kind of tested out both for a while, but I had previously been interested in actually being a bioengineering major, but I when I went to college at the last minute, I changed it to bio. So I always had an interest in kind of the more technical side of science, more of the like engineering way of thinking and approaching problems. Excuse me. And however, when I did a shadow experience before I started college, I didn't think that that was how I wanted to spend my time as an engineer, but I knew that there was still some kind of like math interest in there or like computer interest. It just didn't necessarily look like engineering.
Hmm. Yeah.
So I went through a few different minors and landed on computer science. Um, once I found out that bioinformatics even existed, and then from there, I just had certain research experiences to familiarize myself with the field.
Hmm. That's really nice. Thanks for sharing
Yeah.
your story. So you said you wanted to be an engineer before. One
Mhm.
thing is that people always be like, oh, engineers, they must be very sound in mathematics and
Mhm.
statistics. Was that similar for you too, where you were like very strong in mathematics, or you feel like you don't even have to be extremely good in math before you become a bioinformatician?
Yeah, so I guess computational biology, um, the broader field might have more people who are doing and answering biological questions from an applied math standpoint, but I don't have that background. I was never a math major or anything like that. I wasn't encouraged to take harder math courses because I always did just like okay. Um, and another part of that was I was listening to a lot of people around me and not necessarily myself. And I could have definitely challenged myself more in math in undergrad. But I just had like I got through like algebra in high school and then I did my regular calculus one, maybe two in college. And then I just did another intro to stats course. Um, but that course was actually a little advanced now that I look back on it from taking PhD classes to that. It really did set me up for early PhD level classes, but I wouldn't say that um, you need to be an expert in all things math. There's a lot involved in that, like I said, the calculus, the linear algebra, the sometimes like certain types of understandings of different types of equations and like distributions. Um, those are all things you can pick up, especially within the context of working on a specific project or learning a new area.
Well, thank you. Uh,
Mhm.
I would like to know how your experience was when you started this journey. Was it really easy? because everybody find a lot of people, don't let me say everybody, find
Mm-hmm.
bioinformatics difficult. Right now, I'm doing
Mm-hmm.
transcriptomics, special transcriptomy. I mean, I'm stressing out myself.
Mm-hmm.
Yeah, I've been in bioinformatics, but this is a new fit for me, so it's kind of
Mm-hmm.
difficult. So people always feel that way, and that's why they don't want to move into this field. They find it very
Mm-hmm.
challenging. Did you find it challenging too? And how did you overcome it? Like, how did you handle that?
Yeah, I definitely found it challenging to be able to speak both languages and also figure out, in the early stages when I was doing my first bioinformatics project, which is actually like structural bioinformatics, and there was a lot of machine learning knowledge
I know.
that I needed. And like I found it really difficult because I wasn't necessarily used to yet or familiar yet with having a balance between both. Like I was reading like this hardcore like I was reading like in depth a lot of like physics papers and like proteomics papers and like or just like protein related papers, trying to understand proteomics first before I even did the computational things. But um I think as I matured as a scientist, I've now found a new avenue or kind of like a new way to approach new projects where if I am, starting with a new data type, then I'll probably go back to like my coursework, whether that was in most likely in grad school, because we learned about all the, genomic technologies and omic technologies and things like that. So I'd probably just start from there and um, figure out, what's the most relevant information and then focus on computational tools to capture that type of data and understand what's the best in the field. But to answer your question directly, yeah, it was really hard. Um, and I think it ne doesn't necessarily get easier all around. There's always going to be new challenges, but that's why I think it's good to be in an environment, hopefully like grad school if you're in it, or a research lab, or some sort of job, or somewhere where you're traveling, challenging yourself to constantly um, take on these new challenges and projects so that you understand how to adapt to them. Um, yeah, it doesn't necessarily you never stay doing the same work for, your whole life. You're always going to have to learn something new. But I think that's the beauty of the field is that no one person is an expert on every single thing. Um, so yeah.
Yeah, thank you. I like the fact that you said you read a lot of materials. You read a lot about
Hmm.
proteomics. You try to understand the basics even before you
Hmm.
start. So it means
Hmm.
that it's not all about coding. It's not all about
Hmm.
knowing the technical jargons, but you have to have the basics in both area, both in biology and computer
Hmm.
science. You don't need to have like an in-depth knowledge in both area, but you have to have the basic. Yeah.
Hmm.
So I
Hmm.
really like that point that you mentioned. I have a question too. So you
Hmm.
said that after college you did some internship.
Hmm.
Yeah.
Well, during college, yes.
Oh, doing
Hmm.
doing college.
Hmm.
I would like if you can mention, like if you can talk a little bit about them, like how many were they? Did you need it so much before you
Hmm.
became so confident in yourself, or you just did a couple and you were literally like good to go and you were really
Yeah.
convinced that this is what I want to do?
Yeah, so I guess one, it was my research experiences were spanned between working directly with people already at my university for the 3 of the 4 years that I was in undergrad, and then just one summer, so that was just about 3 months, was an internship. Um, I would definitely say the research experience alone probably would have been good, but I knew I wasn't at a university that had formal bioinformatics curriculum. So I already knew I had to go externally for that sort of experience. And so I interned at the University of Pittsburgh in Pennsylvania, US. And yeah. So it's um actually through the National Science Foundation, NSF, was called a research experience for undergraduates, or an RAU. And so that was a fully funded experience, um, where, I was paid a stipend and given housing and things like that. Um, and so I knew that since I did that in between the summer of my third and fourth year, with my fourth year being my final year, I knew I would only have time for one internship. But what I did was, when I came back for my fourth year after the internship, I just made sure I got more specific experiences, scientifically, that would kind of round out my resume, and ones that I knew that would sort of be supplementary and in the direct path of my interests. So I joined a cancer genetics lab, and I joined because I wanted to get more hands-on wet lab experiment experience. So that in that lab I was working with Drosophila, fruit flies, and so that was a lot of handling flies. And then I also joined a neurobiology laboratory course where I learned how to work hands-on with mice for a whole semester, and like perform different types of dissections and experiments and things like that. Um, I think it's really important too, especially if you have people in your network who are coming from the wet lab side and maybe just want to the experiment side and just want to get some experience with um, analyzing more of their data. Um, I think it's also nice to have that a little bit about that background, so you know exactly where your data is coming from and how it's generated. A lot of people on the computational side don't know that.
Thanks so much. So
Mhm.
in a very simple way, so you were kind of really deliberate about what you want, and you put so
Mhm.
much effort into it. I think that is very important. Seeing that our bioinformatics is not like a very easy course, you just have to really be dedicated, take your
Mhm.
time, know what you want, and go for it. Look for opportunity yourself. Yeah. What
Mhm.
will you
Mhm.
what will you advise someone that is coming from a different field? You came from
Mhm.
biology. It's quite
Mhm.
understandable. Like you have some knowledge of biological part of bioinformatics, but somebody
Mhm.
from, let's say, agriculture,
Mhm.
or someone coming from, let's say, nursing, yeah,
Mhm.
maybe they are going to have some knowledge, but it won't be like you that you were a marine biology student.
Mhm.
So what will you advise them about their journey into bioinformatics?
Yeah, so I think the foundation of bioinformatics is really understanding why it exists, and kind of going from there. Like, it exists because there are certain ways that not only we capture biological data, but we just have so much of it. So um, I think maybe from agriculture, there's a lot of um, like genomic research in that field, I know for sure, where they'd be able to apply, say, RNA-seq knowledge, like getting some RNA-seq knowledge, but the data and the environment is something that you're used to because it's like sequencing on cows or cattle and things like that, or trying to understand, even people who might do like plant biology, who might be interested um, in that. It's different than humans because sometimes there's less data available, there's less tools available, but actually maybe that makes it easier for beginners, since you have, less to choose from. I think a lot of the barrier to getting started in something new too is because there's just so much information out there and people don't know where to start. Um,
Okay,
yeah.
so thank you for your response. I know
Mhm.
that one thing that people actually look out for when you say you're into bioinformatics is they want to see your portfolio. They want to see what you've
Mhm.
done.
Mm-hmm.
How did you develop your portfolio? And yes,
Yeah. The question is, how did I develop my portfolio?
yeah.
So, yeah, it's a little bit hard right now because I'm in a graduate program, PhD program, and I'm in a lab. So not every single thing I do is public, but there are ways that I've worked around that to show sort of skill-based things without giving away sometimes precisely what I work on. Um, since a lot of it is like new or just, a hot topic. One avenue generally is LinkedIn. I make sure I talk about every major event that happens. Someone hears about it, even if, no one is like following you on LinkedIn, just get it out in the open. I think that's one great thing. I also am able to have a website. Um, so if you have the means to fund it, I think a quick portfolio is definitely it's not required, but I think it definitely helps people to get to know me a little bit on a personal level, like an independent scientist level. And then the other thing is, which I think we'll talk about in a second, is GitHub. So I try to showcase, especially for courses where I'm learning a new topic and you can see my journey along the way. I try to put my projects on GitHub if they're relevant. So like for my machine learning course or for my data mining course, I think I have two projects on my GitHub. Um, that show kind of like team collaboration and also that I actually took my courses and spent a lot of time on them. Um, and then the other way is maybe something that people don't think about is just the networking aspect, So I do a lot of networking on behalf of BWCB, but sometimes I have to remember that I'm also like my own scientist
Yeah.
and try to talk about my work if people ask or just try to engage on that. That's another way for people to know, like, oh, I spoke to this person at a conference or at like a virtual meeting, and like she's an RNA biologist and she has computational background, like, so sometimes people just keep that information in their heads. And I also know, you know, some good connections I made at events, whether they're in person or virtual, that have been super helpful. So yeah.
Thanks so much. I like the fact
Mhm.
that you actually pointed out the networking parts. People really don't take it serious, and it's very
Mhm.
important in bioinformatics. You need a lot
Mhm.
of collaboration. Most of the time, you
Mhm.
can't work alone. You need somebody to,
Mhm.
the problem you're trying to
Mhm.
find solution with, whatever you are struggling with. So I like
Yeah.
that point so much. And I like the fact that you also mentioned TikTok. Oh, sorry. LinkedIn. You
Yeah, yeah,
mentioned
yeah.
LinkedIn. Yeah, a lot of people are learning and they are not even
Mhm.
showcasing what they are learning or that
Mhm.
fancy, nice art project they're doing.
Mhm.
It's always a
Mhm.
way to put it out there, even if you don't want to show what the main work is. You can always give a
Right.
snippet of it so that people will appreciate and actually reach out to you for more collaboration or maybe a job. Okay, I'm going to go
Yeah.
ahead now.
Yeah, definitely.
So one challenge that people always face. I think a lot of people don't know about GitHub. Uh, GitHub is something that tech people are used to. Yes, if you say GitHub, everybody knows. But a layman or a beginner, most of the time they just don't know what it means. They don't even know that something like that exists. And as a
Mhm.
bioinformatician, you actually need to start building your portfolio. And the best place to actually have a portfolio, a bioinformatics portfolio is GitHub, just as you've mentioned. Uh,
Mhm.
I would appreciate it if you can just show us how GitHub looks like and walk us through how somebody can have an account and also see other people's account and see what they're doing. In such a way, I
Mhm.
believe the beginner will be motivated to like want to put whatever they're doing on their own accounts, on their own platform, so that people will see their
Mhm.
since you,
Mhm.
yeah. So a lot of people don't know about GitHub. GitHub is more common among the tech people, but someone that is just getting into bioinformatics will be like, what is even GitHub? Yeah. And some people that I've spoken to said that it's just difficult to navigate that that platform. It's not like WhatsApp or LinkedIn that people are familiar with. I'm wondering if you could walk us through how GitHub look like and how somebody can create account and start pushing his or her project onto the platform.
hmm
Yeah.
Yeah, of course. So I'm going to show a little bit of my GitHub, kind of how I use it, how to get started with some things. I think there are a few caveats. And also, if you're familiar or getting used to using bioinformatics tools with R, I can also talk a little bit about what that will look like. Um, so, yeah, I think I'll keep it like this because then you'll be able to see. Okay,
Oh,
cool.
I have a very nice
So,
page.
yeah. So I will here's my GitHub page, here's my homepage. Um and so every GitHub is basically I don't know if you'll talk about that, but it's basically um kind of a wraparound home for a workflow language or version control language called Git. Um you can learn more about Git itself. Um, but we use GitHub essentially to um, interact with the Git version control language or kind of like uh, framework. And so there are many different things that you can do on GitHub. I will also say I'm not like a tech person, so I don't necessarily take advantage of every single aspect on here. But I kind of use it as another space of my portfolio. So I have like what I'm doing. I think it's also nice, if you are online as a professional on other platforms. So here I have my website and my Twitter. Um, and the main things that I have pinned on my website on my GitHub profile are projects that I've worked on, for instance. Um, or a script that I've made that doesn't necessarily give away exactly what I'm working on, but shows that I have experience with a cloud platform called Kavatica and that I've worked specifically with it in certain contexts to manipulate data. But I think people who are on GitHub overlook the fact that this is your profile, you can have your information here, and also um, GitHub, like you can follow people on GitHub and organizations here. So I have like some of my peers on here. I can see um, what certain people in the bioinformatics community are doing. So I know this person does a lot with Bioconductor, for instance. So I like to see what they're working on and how people are contributing to certain things. And but I don't follow too many people, but I think people also overlook that fact that you can follow people on there. So I can walk through maybe some of the projects I have on here. Um,
That would be
and
nice.
I think so. This on the bottom left is what's called a gist or a gist. I don't know how you want to pronounce it, but I pronounce it a gist. And like I said, it's a Python-based script that is essentially interacting with an API or um, I think it's application programming interface, which is basically just how things from one area talk to another.
Mm-hmm.
Um, and so this just shows one, when people are looking at this, I'm hoping that they're seeing that um, I'm well organized in how I code. So even if someone is not familiar with the work that I do, like I said, this has nothing to do with that. Hopefully they can see like, oh wow, she's using like Python arguments and everything is organized and well documented and it's easy to read code. When you're putting things on GitHub, I think that should actually be at the forefront of your mind. Don't put just your scratch projects that you know need to be polished up. Polish up your things first and then put them on there. Especially if you're continuing to work with other people, having well-documented code is really important. Um, so that's one area.
Yeah.
Um,
I'm
Go
wondering if
ahead.
you could show us, yeah, what's tell us a little bit about what you've shown us the overview. What about repositories? I'm a beginner, I really don't
Hmm.
know what I mean. So
Yeah,
a beginner should be like, oh, what is repository? What is project? What are packages?
yeah, yeah. So I will say I don't use packages, and I usually just star things that are other re repos or repositories that I use a lot or that I found interesting. So you can see a lot of these are from my own lab, the Xing lab. Um, and this is actually one of my own art projects. But repositories, or you might hear people call them as repos. Um, some of these are they're basically the base for where your work is going to be. So I can show you one that's actually
So
public.
they are more
Um,
like what I could call folders.
mhm. They're kind of like its own file system. So if you're ever needing to download a project from GitHub, you can do that directly from here by going to code and typing in uh git clone in your command line and pasting this link. And
Yeah.
when you do that, it's going to download everything that's in whatever subfolders you have here. This one just has files
So let's
because it's a
say
project. Yeah.
so for our project, our student will be downloading a PDF file. They're beginners, they don't know how to use our command line. Do you
Mhm.
mind showing them how they can do that without using the
Yeah.
command line?
Without using the command line.
Yes.
Um, okay. So, but will they eventually need to use the command line?
No.
Okay. So in that case, you can just come here to this code drop down and go to download zip. So
Okay.
this is going to download a zip file and you unzip it and that'll be in whatever directory you have. Hmm.
Okay.
I rarely work that way though. So I do recommend people get familiar with the command line,
Yes. That is
start
right.
working around with it. Yes.
Okay. Thanks for showing this. But there is one more thing that our
Hmm.
student would like to know. How can they open an account too?
Yeah. So it's very easy. Let me sign out here. All you need, whoops, all you need is an email and you type that in here and you'll set up your password. And what's really nice with GitHub is that there might be other tools you use eventually in your bioinformatics toolbox that allow you to sign in with a GitHub. For instance, I use Visual Studio Code or VS Code to edit a lot of my Bash scripts and sometimes my Python or R scripts in general. And I can log in with GitHub to like save my work or do other things through that connect VS Code to GitHub. Another thing that your login gives you is if you are you working in R Studio and you want to publish your code directly to GitHub, then once you log in and make an email account, you can Google this or look it up online for this specific workflows, but you can connect them by setting up uh, like an API key or kind of just like a passcode or a PIN that you can talk to our studio with so that once you are starting to develop scripts in R, you can push them are what's called basically like you're publishing, making final changes to GitHub directly from your RStudio interface. So this was really helpful when I was working with other people on things like homeworks or projects because we could just work on different versions of our scripts and like kind of send them back and forth to each other. Um, but that kind of got carried away. But yes, you just go and sign in here. It's free.
I have a question too.
Mhm.
We are dealing with a lot of people that are new to GitHub and
Mhm.
they don't know how to use the command line yet. How can they still push their codes or push their, let me say, document to
Mhm.
their GitHub account? Is there a manual way of doing that, an easier way?
Can they push a document?
Or let me use the word upload so
Mhm.
that, yeah, everybody is familiar
Yeah,
with the upload.
you
Yeah.
can. So you can completely use GitHub kind of like as your own file share. Let me show you quickly.
Okay.
Trying to see if there's one. Okay. So for instance, if I want to upload something, I'm going to come over here to add file, and I can either create a new file, which is what I generally do, or go to upload file. So you can just like you see here, I have just like PDFs here, and these are like syllabi of my old classes that I've taken related to statistics and machine learning. This also goes back to how I showcase what I do, because this repo is not necessarily like code or work. It's literally just I've listed out every class I've taken related to machine learning and statistics because I know those are my interests and I know people will find them. But coming back to this, you can just upload files or if you want to take notes, which is how I frequently use GitHub, um, you can go to create new file and then name your notes. And GitHub also works with what's called the Markdown language, which is basically just kind of like a scripting language in how we format our work. So you can say, like, this is a title by using one hashtag, I think. This is a subtitle, and this is regular text. I think that's the order of them, but let's see. And then you'll go here to commit changes. If you're working extensively on some notes, you can write your notes here and add a description, but you just go to commit changes here. And so once I go to the My Notes document, it's here in my main folder. I can click that and you'll see it's all there. So the Markdown language changes your main basic text into something that's probably more readable,
Yes.
so that you can organize better. So you can see I've used different levels of this text here. Hmm.
Thanks so much. Like this is
Yeah,
very, very detailed. Uh,
of course.
one
Yeah.
last question. I
Yeah, yeah.
know if there is a way to connect, yeah, you said we can follow people on link on GitHub. Is
Hmm.
there like a community on let's say on GitHub that
Hmm.
let's say I'm a beginner, a community I can actually follow and kind of get motivated because I believe when I see other people doing something great, I want to do similar thing. So I don't,
Hmm.
are there communities like that?
Yeah, so I actually recommend that people follow communities like Bioconductor. They have an open Slack page, so if you search up Bioconductor on Google or just Google like search Bioconductor Slack, then you should be able to enter that Slack community. And in there, there are people who are talking specifically about bioconductors. So, and I think people who might be learning bioinformatics might be a little bit more familiar with R first. So as you're learning R and trying to understand some new tools, then that's definitely a good community to be in to ask questions related to bioconductor packages or other topics. And it like bioconductor is like open source, so they're really focus on sharing work and, resources and things like that. And then I would say for people who are a little bit more intermediate to advanced, it might be more leaning toward software and biology, so like software development on more the computer science side. There's another community called Bits in Bio, and they also have a Slack that's open. There's thousands of people in that. And there's a bioinformatics Slack channel within that workspace. Um, Finally, there's another resource called Figure One Lab. So, um, this is a initiative started by someone named Dean Lee at Novartis,
Yeah,
and
I've heard the name before.
yeah, so he has put together a full tutorial. You're gonna have to read this through and see what's relevant for you. But his main goal is to really empower people not just to learn computational biology or do comp bio projects, but to do so with the purpose of showcasing them for future employment. So he directs you to papers that have data available, and he walks you through everything from downloading to getting some early figures. That's why it's called Figure One Lab, so that you can kind of reproduce the first figure of a research paper. Um, and it's all GitHub based too. So this might also expose you to just how to navigate GitHub. You can maybe, I would recommend cloning this repo or downloading a version of it just locally so that you can read through the documents and just like go to the links, you know what I mean? So yeah, this is another resource that I recommend. And we've done a podcast, Black Women in Comp Bio, BWCB. We've done a podcast interviewing Dean Lee on the Comp Bio Cafe podcast. So feel free to check that out if you have time.
Thanks so much, Jenny.
Yeah,
This
yeah,
is
of
really
course.
cool. I mean, even if you've never heard of GitHub before and you listen
Mhm.
to all these, I mean, you are going to really understand what is it and how you can make use of it. Thanks so much. And
Yeah.
I'm very certain that this will really be helpful to a lot of people out there. I mean, you've given
Hmm.
us a big trial. Thank you. And thanks for coming to our podcast too.
Yeah,
I
of
would
course.
like to ask, what will be your final word before you leave this broadcast to someone struggling to enter
Mhm.
this field?
Yeah, I would say don't wait to kind of show what you're doing. I think it's nice to have a platform or a place where if it's how you communicate and express yourself, to show your journey of learning. Not everything needs to necessarily be perfect, but I really think that people who can get used to showcasing what they're doing and talking about what they're doing in an accessible way, um, emphasis on that is something that really shows a deep knowledge and understanding of their topic. So especially bioinformatics, just kind of stick to one path for now. Don't try to learn every single thing or every data type or every tool that's out there. Um, Focus on telling one story with data, um, and go from there. But I think the but don't wait until it's, like perfect or like you're looking for a specific answer in your data. Just get started somewhere and get used to talking and expressing what you're doing as a scientist.
Yeah, thank you. I'm going to hold
Yeah.
on to that myself. I'm not going to,
Okay.
I'm going to start sharing whatever I'm doing. Thanks so much for your time.
Hmm.
I really appreciate you. Thank you for coming. And I hope that we get to collaborate more on projects,
Yeah.
yes, on projects and on impact related stuff.
Yeah, yeah, of
Yeah,
course. Thank you for having me here, and
you.
it was really nice to get to know you. And
Bye.
yeah,
Have
bye-bye.
a lovely day.
You as well. Bye-bye.
Yeah, bye.